The set I'm showing you today is what is known as a 0 to 1 inch micrometer. Get my pointer out here, which just says right there, and it goes up to the 10th of 1,000ths, so 4 decimal points over. And you're probably asking yourself, I don't understand any of that stuff. What the heck does that mean? Well, let's close this down. So we just spin this. Now, I never clamp it super tight as far as, when I put my tools away. I just get it, with a couple thousand, like 10,000ths or so. But if you were to close it up all the way, the lines, I'm not going to do it, but the lines would, the 0 and the 0 mark would line up. And that would be 0. There's nothing you can measure. And then when you go all the way, right, okay. Oops, went past. Right there is exactly 1 inch. All these lines here, 0.1, 0.2, 0.3, 0.4, 0.5, which is a half an inch, 0.6, 0.7, 0.8, 0.9. Now we're at 1.0. Where are all these lines in between? Try and get it here real close. See if I can get it to focus. All these lines here are 25,000ths of an inch, which means for every turn of this thimble is 25,000ths. So you see it 1, and it gradually goes up 5, 10, 15, 20. The last number you see is 24, then it resets back to 0. So in theory, this went 25,000ths. You're asking yourself, I'm confused. How the heck do I say someone threw something at you and it landed? I don't know, right there. You're like, what the heck? Where is this? Well, we already know you're at 0.700, and I see if I can get really close here without it going too crazy. I see there's one line which represents 25,000ths right there. Sorry, I'm shaking. So we're 20. So we got 7, and you've already gone past one of the lines, so it's 25. So if you were, say that would be 725, and we landed, I don't know, I can't remember, somewhere around in here. So now we have to add this set of numbers to this. So we're at 725, and we ended up somewhere around here. So there's 5, and we're not quite at 6. So currently, 5 plus the 725, so you're taking 0.725 plus 0.005, which is 5,000ths. So you add that, you have now what is known as 0.730, because you added the 25,000ths and the 5,000ths. So that dimension so far is 0.730. But when you look at it, you're in between these two marks. You're like, okay, well, technically it's really not 0.730. It's somewhere in between. So let's lock this. so I don't lose it. And we're going to come up here. We're going to look at these numbers here now. Pay no more attention to this stuff. No number. Don't want to look at these now. All you want to do is try to, you got all these lines here. These are your tenth of a thousandths increments. You're going to try and match one of these lines. And I'm trying to look at my monitor and at my mic at the same time. Now it looks like the number 5 from what I could see. See if I can zoom in here. Yep. It looks like the number 5 is lining up with this. When you go down to number 4, it's just a smidge off. And when you go up to number 6, that's a hair off. And 5 is the closest one, and it lines right up. So you're really not paying attention to any of these lines over here, or I'm sorry, the numbers. You just want to line up which line looks like it's parallel with whatever's on this thimble with this line on the shaft. And that would be number 5. There it goes. So you have a dimension of what is known as 0.7305, and that's your 4 decimal places. Now if you were doing a print, which most places, you know, they may call for like a dimension of, say, I don't know, 0.700 plus or minus 1/1000. So what does that mean? Well, you're going to come down. There's 700. What's plus or minus 1/1000? Well, there's 1/1000 positive, 701. Negative, that would be 699. Right there. So, that's what that means. I hope I didn't confuse anybody. And, where's my tool? What's this thing here? It's a lock mechanism. So when you want to measure something and have it hold, let me see if I can find something here floating around. Say you wanted to drill a hole and you don't want it to be like really huge. You just want the screw to go through clearance wise. And you can mic up the screw, and let's see what that is. And all I'm doing on my micrometer, you don't have to crank on it. This thing will actually, it's like a little spring, and it keeps just enough pressure on that so it won't fall out. Let's see where we're at. And while we're at it, we'll lock this, and that way it won't spin, or you won't lose your dimension. So let's see here. Let's count this out together. Well, we got 1. 2's not visible, so let's start going down here. There's 25. There's 50. I don't see the 75 line. So let's say, okay, 100, 125, 150. We're at 150 plus the 15. So 150 plus 15 is 165. So if you wanted just to be kind of accurate, you're really at 165. But if you want to be totally accurate, we're in between the two. So we got 0.165 165, because you got the 50 plus the 15, so that's 165. And let's get to the fourth decimal point. Okay, remember, pay no attention to these numbers anymore. You just want to line up the lines. Okay, we're rotating around 5. Yeah, let's see here. It looks like 6/10 is the line that lines up right there. 6/10. So it is 165 and 6/10, or 0.1656. But someone said, I need a set of 3 to 4 inch mics. What the heck's that? It's the same thing. It's just, it measures from the starting point would be 3 inch here, and your ending point would be 4 inch right there. And it's pretty much, this one only goes 3 decimal points. This one doesn't have the markings like my smaller mic. It doesn't have all the tenths. So if you were to measure something like, let's see, we'll just throw this around. I don't know, we'll just stop right there. 3 inches. Oh, let's go. There's 8. See if I can get closer on this. 25, 50. We're almost to 75, right? This would be 75. That would be when we stop right there. So that's 73, because you're taking the 50 plus the 23. And then when if you went up to here, that would be 875, 76, 77, 78, 79, 80, because you're adding on these numbers to this. Remember, these are 25 thousandths a piece, these lines going up and down. So we end up, I think, we were down. That's how that works.